Hello friends, a very warm welcome to another session pertaining to CSAT examination, and today's topic is directions. Well, in any examination you can expect at least one question on directions. Let us have a look at the basic concepts and then let us find out how we can apply these basic concepts, and then let us know how we can apply these basic fundamentals to solve the questions correctly and within no time. So directions are very important in life, and compass is that instrument which is used to indicate the directions. Now this is a compass as it is visible to you, and in this compass you would find that there are 4 primary directions and the other 4 are secondary directions. Now let us look at these directions a little bit more in detail. So first let's have a look at 4 primary directions. The first direction is north, and this is how we point towards north. Second is south. This is how we will point towards south. So north and south are opposite directions. Now similarly, east, which is to our right hand side, and west, which is to our left hand side. So east and west are opposite directions. Now let's talk about 4 secondary directions, which are actually located in between any 2 primary directions. First is northeast, which would be between north and east directions. This is how it will look like. Then northwest, it would be between north and west, and this should be the direction between north and west. Then southeast, which should be between south and east. This is south and east, as you can see here. And finally southwest, between south direction and west direction. So questions are asked pertaining to these primary directions and these 4 secondary directions. Now certain basic fundamentals. While solving a question, assume that we are always facing north direction by default. So this is north direction and this is us. So we are facing towards the north direction. So this is left and this is our right hand side. So in a question, if it is given to you, for example, that Ram is facing towards north or walks X kilometers towards north direction and then takes a left turn or a right turn, then Ram's left and right is going to be the same as our natural left and right. Now, if a person is facing the north direction, then his left and right side is the same as our natural left and right side, as I have just discussed with you. This is you and this is your left and this is your right direction. Now, if a person is facing the north, then east will always be to his right side. So here you are facing towards north and east is towards your right side. Next, if a person turns towards left or right side, so turning towards right or left is always a 90 degrees turn. Now this is you. Currently, you are facing towards the north. So you take a right turn, that means you have turned by 90 degrees. Similarly, if you will take a left turn, you will turn by 90 degrees. Now, if you are facing a particular direction and you take 2 left turns or 2 right turns, then you will face the direction opposite to the initial direction that you were facing. For example, if you are facing north and you take a left turn and again you turn towards left, that means you would be facing south. So let us assume this is you. Initially you are facing north. Now this is your left side and this is your right side. So you take first left turn like this and then once again you turn left. So currently now you are facing towards the south direction, that is opposite to the initial direction that you were facing, that was north direction. So initial direction that one is facing, from there if a person takes 2 left turns or 2 right turns, then he would be facing the direction opposite to the initial direction. So let us say a person initially is facing towards east, then he turns towards right and then once again he turns towards right. So he has taken 2 right turns. So now he would be facing towards the west. Now, if a person is facing any direction, then after once turning towards left direction and then turning towards the right direction, will make the person face the same direction. In short, it means one left turn cancels one right turn. So let us say this is you. This is your left and this is your right. So first you turn towards your left and then you turn towards your right side. So now you are back to the original position wherein you were facing north when you started turning towards left and then to right. And after making these two turns, one left and one right, you're back facing the north. Now it could be that a person starts walking from this point, goes straight, turns right. Now you have to find out the distance between this person and the starting point. In that case, you have an inclined line. So take the vertical and horizontal component of this inclined line and apply the Pythagoras theorem to find its length. So here you see an inclined line and you want to find the length of this line. Take the vertical component and the horizontal component. You shall get right angled triangle. This is the right angle. So as you know, this is perpendicular, this is the base, and this is the hypotenuse. So perpendicular square plus base square equals hypotenuse square, or we can say a square plus b square equals c square. From this, you also get the square root of perpendicular square plus base square equals hypotenuse, which is the length of this inclined line. Now let's have a look at some questions here. Now these questions are based on the basic fundamentals that we learned just now. Seema's house is facing the north direction. Alright, so let us say this is Seema's house and it is facing the north direction. So this is north, as we know. While going from her house to market, she takes 2 left turns, then 3 right turns, then 4 left turns, then 5 right turns. So initially, Seema is facing towards north. She takes 2 left turns, then 3 right turns, then 4 left turns, and finally 5 right turns. At the end, which direction is Seema facing? Now, are you actually going to turn this person the number of times it is mentioned in the question towards left side or right side, 2 times left, then 3 times right, then 4 times left, then 5 times right? In that case, you will take a lot of time and this is a tedious process. So there are always going to be chances of committing an error. Rather than doing that, we have already learned that 2 left plus 4 left, there are in total 6 left turns. 3 right turns and 5 right turns. In total, these are 8 right turns. So we can reduce this to north plus 6 left turns plus 8 right turns. Now we can rewrite this as north plus 6 left turns plus 6 right turns plus 2 right turns. Well, 8 can be split into 6 plus 2. Now we are very much aware that a left turn will cancel a right turn. So 6 left turns cancel 6 right turns. So we are left with north plus 2 right turns. Also we are aware that if a person is initially facing a direction, let us say north, from there, if the person takes 2 right turns or 2 left turns, the person will face the opposite direction, and that is south. So at the end, which direction is Seema facing? It is south. Now similarly, have a look at this question. Ram is facing the east direction. Alright, so this is Ram and he is facing the east direction. Standing at his place, wherever he is standing, he turns 102 times to his right side. So east plus 102 right turns. Now towards which direction will Ram be facing finally? Now we know that if a person here is facing towards east, this is his left and this is his right. If he turns towards right side, this is his first right, he would be facing south. Second right, he would be facing west. Third right, he would be facing north. And fourth right, once again, he would be facing east direction. So any person, let us say, who's facing east direction, if he takes 4 right turns, then finally he would again come back to the original position, that is, he would be facing the east direction. Now the nearest multiple of 4 we know is 100. So here we will split 102 as 100 plus 2. So 100 right turns plus 2 right turns will be 102 right turns. Now 100 we know is 4 into 25. So there are 25 sets of 4 turns each towards the right side. And every time the person takes 4 right turns, he would come back to the original position. So it means east plus 100 right turns should get Ram back to facing east. Remainder is 2 right turns. Now once again east plus 2 right turns. That means that he should be facing towards the west finally. So here we are employing the same fundamentals that we had learned at the beginning of this session. Now one thing more, you might face a little bit of problem when a person is turning towards left or right when he is facing towards east or he is facing towards west. Now for that, I'll tell you some simple methods here. Let us say this is the compass, north, south, east and west. We already know that when a person is facing north, his left and right sides are the same as our natural left and right side. So let us write this L and R in clockwise direction, but in alternate fashion. So L, R, this is L, this is R, this is L, this is R, this is L, this is R. Now you know left and right of each of the directions. Now this is one method. The second one is, if a person is moving towards right side, that means he's moving in clockwise direction. And conversely, if a person is moving towards anti-clockwise side, that means he's moving towards the left side. So right is clockwise, just remember that. Opposite of right is left, so opposite of clockwise is anti-clockwise direction. Apart from that, you should know that whenever you are going to solve questions based on directions, you would be drawing a diagram in rough. Now, let us say that you draw a diagram like this, and this is your starting point. Now, when you see that initially this person was facing north, his left and right is going to be the same as your natural left and right. So now, if he's turning left, this is left, this should be L, this should be R. Go like this along these arrow marks. L or left would stay on the same side. It won't change. So this is left, this is right. Finally, this is left, this is right. Now you know if he has to turn towards left, he has to move towards north. And if he's going to turn towards right side, he would be moving towards south. So this way you would know the left and right side of a person while you're drawing the diagram. Now this is a set of instructions which is given to you for 5 questions actually. Mohan drives 5 kilometers towards north from his house. Then he takes a right turn and drives 5 kilometers. Then turns left and drives 5 kilometers. Then turns left and drives 10 kilometers. Finally, he turns left and drives 20 kilometers to reach his office. Now the questions are, how much distance did Mohan drive? In which direction is Mohan's house from his office? In which direction is Mohan's office, the destination, from his house, that is the initial position? How much is the shortest distance between Mohan's house and office? At the end, towards which direction was Mohan driving? Now let us learn how to draw diagrams in rough for such kind of questions. First, I have noted down this question in short. 5 kilometers north, then he takes a right turn, goes 5 kilometers, then 5 kilometers to left, then 10 kilometers to left, and finally 20 kilometers to left. He reaches his office. So let us start with the first instruction. Let us say this is his house. And then he moves 5 kilometers north. This is north. So 5 kilometers. So his left and right should be the same as our natural left and right. Then he turns right. Then he turns towards his right hand side and drives 5 kilometers. So this is where he turns towards his right hand side, drives 5 kilometers. Now this is where his left and right should be there. Then he turns left and drives 5 kilometers. So this is where he turns left, drives another 5 kilometers. Now this should be his left and right. Then he turns left and drives 10 kilometers. Now this is left. So this is how he drives 10 kilometers. That's very important for you to know while drawing the diagram, that the lines that you draw or the arrows that you draw to represent a particular direction. Now the length of those arrows should maintain the length in such a way that the arrow which represents 10 kilometers of distance should be longer than the arrow which represents 5 kilometers of distance, if not exactly twice, if not exactly double. So here we see that this is the length between this point and this point. As every time a person turns left or right, he is turning by 90 degrees. So we get a square or a rectangle. So if in this parallelogram, this is 5 kilometers, the opposite side also is 5 kilometers. This is 5 kilometers, the opposite side is 5 kilometers. So out of 10, this is 5. So the remaining 5 is this. So do not end the line or the arrow mark at this point. It will be incorrect. You have to go beyond it and end it somewhere here, so that the length of the arrow which represents 10 kilometers is longer than the length of the arrow which represents 5 kilometers here. Now once again, left and right. Finally, he's turning towards left and driving 20 kilometers. Now once again, if you see, 5 kilometers to the north, 5 kilometers to the north. So from the house to this point is total 5 plus 5 here till this point, that is 10 kilometers. So similarly, from here to here, you will see that this 20 kilometers, which is appearing here, up to here it is 10 kilometers, and then remaining 10 kilometers is beyond this line towards the south. All right, and that is when he reaches his office. As you can see, this is the distance between this point and the house. And again, here you see a rectangle. So opposite sides are equal. If this is 5, then this is also a distance of 5 kilometers. Now, total distance driven is what has been asked in the first question. Total distance driven is the actual distance driven, which is nothing but it is the sum of these figures which are given to us here. So 5 plus 5 plus 5 plus 10 plus 20, the total should come out to be 45 kilometers. That is what his speedometer will also indicate. Now, in which direction is his house from his office? So, whichever place is given to you after the word from, you stand there and watch the initial position. Now, this is what? This is office and this is the house. So, from office to house is this direction. This direction we know is well between north and east. So, it has to be northeast direction. Now, any point between north and east direction is northeast direction. Now, in which direction is his office from his house? Now, stand at this particular place wherein you are viewing his office from his house. So, it comes out to be this direction, which is like this, which is between south and west. So, obviously, southwest, which is directly opposite to this. You can see north is opposite to south and east is opposite to west. So, if I look at you and you are in my northeast, then I am in your southwest, just the opposite, because we are facing each other. Now, shortest distance between house and office is this, as you can see. Once again, it is an inclined line, so you would make use of Pythagoras theorem. So, you get a right angled triangle here, something like this. This distance is 5. This distance, is 10, and you have to find out the length of this inclined line. So, 10 square plus 5 square whole under root should give us root 125, which can also be given to you with the choices as 5 root 5 kilometers. Now, finally, he is driving in which direction? Now, finally, we know he is moving towards this direction, towards his office. So, that is nothing but south direction. Now, these are 5 very common questions which are asked to you. Now, if only this question was asked, that is the 5th one, finally he is driving towards which direction, you don't have to draw the diagram. Now, you remember that when only direction needs to be determined, then you don't need the distances. So, north is the direction that initially he is facing, then he turns right, next he turns left, next he turns left, and finally he turns left Now we know that a right turn and left turn, they cancel each other. They're opposite directions. So now we are left with north plus 2 left turns, which means this person would be facing south direction. So if this question was for this set of instructions, the question asked was towards which direction is he facing finally, then you don't need to draw a diagram. But to find out the distances and to find out his final position from the initial position and vice versa, we will require a diagram, which you will make in rough. Now look at this question. One morning at sunrise, Mohan was walking in a garden when he sees his friend Ravi approaching him from the opposite direction. On meeting each other, when they shake hands, then Mohan notices that Ravi's shadow is falling exactly on Ravi's right hand side. Now towards which direction is Mohan facing? Now the question is about Mohan. So let us become Mohan. This is Mohan and this is his friend Ravi, who was approaching him from the opposite direction, and then both shook hands also. So here they are shaking hands. Now we are facing Ravi. So this is our left and this is our right. I know the hands are quite long, and when two persons are facing each other, their right and left hands are opposite each other. Now you're viewing me. This is my right hand. Now this is pointing towards your left hand. This is pointing towards your left hand side. Now this is my left hand, which is pointing towards your right hand side. So that means that Ravi's left and right are going to be just opposite to our left and right side. Now Mohan notices that Ravi's shadow is falling exactly on Ravi's right hand side. So this is Ravi's right hand side. So let us say this is ground. So Ravi's shadow here is falling like this on his right hand side. This means that Mohan's shadow will also fall in this direction. That is Ravi's right hand side. And Ravi's right hand side is Mohan's left hand side. Now we are talking about shadows. What forms shadows? A source of light. Now what is the source of light here? One morning at sunrise. So sun here is the source of light. And obviously a shadow is formed on the opposite side of the source of light. Whenever the object is there between source of light and the shadow, if this is the object and this is the source of light that we have, the shadow will be formed on the opposite side, that is the back side. So that means that sun must be somewhere here on the horizon, and we are talking about sunrise, where the sun is horizontal. Now we know that during sunrise, sun is in the east. So east is towards our right hand side, towards the right side of Mohan. And we just learned that whenever a person is facing north, east is towards his right side. Conversely, if east is towards the right side of a person, that means the person is facing north. Early morning, if at all you are taking a walk and you find that sun is towards your right side, that means you would be walking towards the north. Now, case 2, early morning, if at all you're taking a walk and sun is to your left side, that means you're walking towards south direction. Now, case 3, during evening, let us say that you're taking a walk and sun is on your left side, that is in the west. That means you are heading towards the south direction. Now, case 4, in the evening near sunset, you're taking a walk and sun is on your right side. That means you're moving towards south. Case 3, on an evening during sunset, let us say you're taking a walk and sun is on your left side, that is in the west. It means that you are heading towards the north. Case 4, during an evening at sunset, you're taking a walk and sun is on your right side. That means west is on your right side, then you're facing towards the south direction. So in which direction is Mohan facing now? He is facing the north direction. So such kind of shadow-based problems have been asked in various examinations. So get acquainted with this type. In this question, Arun goes 5 kilometers south from his house. Then he turns right and goes 10 kilometers. Then he turns 45 degrees left and goes 30 kilometers. Now if Arun wants to go back to his house via the shortest route, then towards which direction must he go? Now again, there is a question which is involving direction from the final position to the initial position. So you will have to draw a diagram here. Let us say this is Arun's house. He goes 5 kilometers towards the south from his house. Then he turns right. Now this is left and this is right when a person is moving towards south. That means the person is facing us. So the left and right sides are opposite to our natural left and right side. So now he turns right and goes, let us say, 10 kilometers. Now this is where his right side and this is where his left side. Then he turns 45 degrees left. Now there are two cases which I would like to discuss with you here. Now currently the person is standing here. Now in the first case he could be moving in this direction, which is 45 degrees from this arrow mark. And another case in which this is where the person is. He's moving in this direction, which is 45 degrees from here, from this line. Where should he move? As per the first case or as per the second case? Because in each case he is moving towards the left. Now the point here is that this is the direction in which he was moving. If he takes one left turn, it is already 90 degrees. Then another 45 degrees he has to move and then move in this direction. So in total, the person has turned 135 degrees towards left. If he would have turned another 45 degrees, it would become a U-turn. So this is incorrect. So 45 degrees turn is half of 90 degrees turn. Now if this person would have turned towards his left, this is left and this is right, then he would have turned towards the south, this direction. But 45 degrees left would mean half left turn. So it has to be in between this straight ahead road and the left turn road. So here, correct direction shall be this. From here it is 45 degrees and this is 30 kilometers. So this is the final position of the person. Now if Arun wants to go back to his house via the shortest route, this shall be the shortest route. Then towards which direction? We just need to find out direction. We don't have to calculate the distance. So he has to move in this direction. Now this direction is in between north and east. So he has to move towards northeast. So your answer here will be that if he wants to go back to his home, then he must walk in northeast direction. Now there is one more fundamental that you must learn, and that is any point which is there between north and east, it would be considered in northeast direction. But if a question says that Ram walks 5 kilometers towards northeast direction, in that case, that northeast direction that you will have to consider has to be exactly in between north and east direction, that is 45 degrees from each of these primary directions, right in between. But if you need to find out in which direction the person has to move or in which direction is his house from his final position, then any point between north and east is going to be northeast direction. Now, Sarah was participating in a dance competition. Initially, she was facing the southeast direction. First, she turns 90 degrees clockwise, then 180 degrees anti-clockwise, then 90 degrees anti-clockwise. Now, towards which direction is Sarah facing? So, first thing is, please know that this movement towards our right hand side is clockwise. When you are tightening the cap of a bottle, now that movement is clockwise. And obviously, opposite to that is anti-clockwise. When you are opening the cap of a bottle, you are opening the cap of a bottle, you are basically pushing it to your left. Now here you don't need to draw a diagram and literally move this person in various directions. That would take a lot of time. So first things first, she was facing southeast direction, and then from there she turned 90 degrees clockwise, then 180 degrees anti-clockwise, and then 90 degrees anti-clockwise. Now we know that clockwise and anti-clockwise directions are basically opposite direction, moving towards right and moving towards left. So 90 degrees clockwise direction and 90 degrees anti-clockwise direction will cancel each other. So now we are left with southeast direction plus 180 degrees anti-clockwise direction. Now 180 degrees anti-clockwise or clockwise would actually mean moving to the opposite direction. Now this is a straight line. If you move it towards clockwise direction or anti-clockwise direction and you turn by 180 degrees, it'll just point towards the opposite direction. Doing it again, if this pen is pointing towards the north and you have to move it by 180 degrees, this is 90 degrees, another 90 degrees, now it is pointing towards the south direction. So southeast plus 180 degrees is opposite side. Opposite of south is north, opposite of east is west. So our answer here is that finally she is facing towards the northwest direction. Now the time shown by a clock is 3 o'clock. Now we are talking about the analogous clocks, not digital clocks. If the minute hand of the clock is pointing towards the east, then towards which direction will the hour hand point? Now you know, let us say that this is north, south, east and west. This is 12, this is 3, this is at 6 and this is at 9 with 1 and 2 here, with 4 and 5 here, with 7 and 8 here and with 10 and 11 here. So how do you see 3 o'clock? Well, this is how we actually see 3 o'clock in a clock. This is minute hand and this is hour hand, the smaller one. Now the minute hand of the clock is pointing towards the east, but here the hour hand is pointing towards the east. The minute hand is pointing towards the north. Then how will it point towards the east when the minute hand is pointing towards the north? Because this is how 3 o'clock looks like and this is minute hand, and if it is pointing towards the north, then how can it point towards the east? Well, it can happen only if you rotate the clock by 90 degrees. Now, the minute hand is pointing towards the east. Now, I would show you this with the help of a diagram here. As you can see, we have rotated the clock here by 90 degrees in the clockwise direction. This is where is 12, this is where is 3. That's the only way when minute hand can point towards the east. Now when minute hand is pointing towards the east, towards which direction is the hour hand pointing? It is pointing towards the south. So your answer here should be south. Now let's have a look at another question of similar time. The time shown by a clock is 7:30. Now if the hour hand of the clock is pointing towards the southeast, then towards which direction will the minute hand point? Now let us say this is how we have a clock with 4 directions as I am giving you here. This is 12, this is 1 and 2, this is 3, this is 4 and 5, this is 6, this is 7 and 8, this is 9, this is 10 and 11. Now what do you see at 7:30 in a clock? The positions of minute hand and the hour hand are somewhat like this. The minute hand is exactly at 6 o'clock and the hour hand is right between the 7th and the 8th hour division. So this is how it looks like. Now the hour hand of the clock is pointing towards southeast is what is given in the question. Now currently this is the direction in which the hour hand is pointing. This is the minute hand. And this direction, as we know, is right between the west and the south. So this is the southwest direction. But the question says that the hour hand of the clock is pointing towards the southeast. That is, it should come here. So for the hour hand to occupy this position, we will have to rotate the clock by 90 degrees in anti-clockwise direction. And this is how it looks like. Now we rotate. So this is where the position of the hour hand is such that now it points towards the southeast. Now towards which direction is the minute hand pointing? The minute hand is pointing towards the east direction, as we can see. So our answer here shall be east direction. Now one more thing which I would like to point out here is that the primary directions, the adjacent primary directions are always at 90 degrees. Opposite one is going to be at 180 degrees. And the adjacent secondary directions will also be at 90 degrees. So this southwest and this southeast are at 90 degrees to each other. Always remember that. That's how you will solve questions. Now, a person X was driving in a place where all roads ran either north-south or east-west, forming a grid. Now, roads are at a distance of 1 kilometer from each other in a parallel. So let us form these roads. And here he is saying roads are at a distance of 1 kilometer from each other. That means from here to here, the distance is 1 kilometer. From here to here, the distance is 1 kilometer. From here to here, the distance is 1 kilometer. And from here to here, again the distance is 1 kilometer. So you find that there is a grid in which each cell is a square. Now the question says he started at the intersection of two roads, drove 3 kilometers north, 3 kilometers west, and 4 kilometers south. Now, while driving the diagram, you should be very careful because you will need to move 3 kilometers to north and then 3 kilometers to west and then 4 kilometers to south. So this is how your diagram will look like. So you can start at this junction. So that 1, 2, 3. 3 kilometers this person has moved towards the north. Then he moves 3 kilometers to west, that is, he needs to turn left here. So 1, 2, 3. Now this is the point that he reaches. This is 3 kilometers towards the west. This is towards the north. And 4 kilometers south. So from here 1, 2, 3, and finally 4 kilometers, as you can see here, towards the south. So this is his final position. Now the point is, which further route could bring him back to his starting point if the same route is not repeated? So we will check for all the routes given to us amongst the choices. 3 kilometers east and 2 kilometers south. Well, he can go 3 kilometers towards east, but then he needs to move 1 kilometers towards north, not to south. So A is out. 3 kilometers east and then 1 kilometer north. Yes, this is what we want. So from here, he should be moving 3 kilometers towards the east and then finally 1 kilometer towards the north. Now this is going to bring him back to the original point. So choice B is absolutely correct. Now a person climbs a hill in a straight path from point O on the ground in the direction of northeast. If a person is moving towards northeast, while solving the question and drawing a diagram, you will have to assume this is perfect northeast. So the person starts from point O, moves towards the northeast direction and reaches a point A, which is given here, after traveling a distance of 5 kilometers. This is 5 kilometers. Then from the point A, he moves to point B in the direction of northwest. So this is northwest. Now let the distance AB be 12 kilometers. So this is 12 kilometers from A to B. Now how far is this person away from the starting point O? So you need to find out this line or this distance. So what you see here is that northeast and northwest are going to be at 90 degrees from each other. So we have with us now a right angled triangle, and to find out this distance we will employ Pythagoras theorem. Now one thing that you can do is do these calculations. 5 square plus 12 square under root, that is 25, plus 144 under root, that is 169 under root, which is 30. Takes time. Now rather than doing that, I suggest you to memorize Pythagorean triplets. They're going to be of tremendous use to you. Now these are 3, 4, 5. That is 3 square plus 4 square is equal to 5 square. That is 9 plus 16 is 25. Then 5, 12, 13. Then 8, 15 and 17. And then 20, 21 and 29. Now there are multiples also. That is 30, 40, 50 or 6, 8, 10. These are also Pythagorean triplets. Now here, if you remember this, then 5, 12, 13 should immediately strike to you and you will save this much of time. So hence Pythagorean triplets are very important from the examination point of view, because many a times questions have been asked which involve Pythagorean triplets. So anyhow, 13 kilometer, choice B happens to be the correct answer. A person walks 12 kilometers due north, then 15 kilometers due east. Now let us draw a diagram for this. Now this, let us say, is the starting point. From here the person walks 12 kilometers towards north. So let this be 12 kilometers to north. This is left, this is right. Then 15 kilometers due east. 15 kilometers is to the right side. That is towards east. This is left, this is right. After that, 19 kilometers due west. After east, when he is moving towards the east, then he has to take a U-turn and then go towards the west. So he takes a U-turn till 15 kilometers, he comes back to this point. So from here, if he is going back till here, it is 15. So go back a little more by 4 more kilometers so that he goes back by 19 kilometers. So 4 more kilometers here, he moves. Now he is facing west. And then 15 kilometers south. So from here, moves towards south. So we know, and from this point to this point, this is 4 and this is a parallelogram. So this much distance up to this point should be 12. But we want 15 kilometers. So he will go 3 more kilometers in this direction. Now this makes it complete 15 kilometers towards the south. So this is the final position of the person. How far is he from the starting point? Alright guys, so this distance is 4, this is 3, so 3, 4, 5, the Pythagorean triplet. So this person is 5 kilometers away from the initial point or the starting point that is given to us in choice A. That becomes the answer. Shahid and Rohit start from the same point in opposite directions. After each travels 1 kilometer, Shahid always turns left and Rohit always turns right. Which of the following statements is correct? First of all, let us set their movements as per the directions given in the question. Now this is, let us say, the starting point. This is where Rohit is moving and this is the direction in which Shahid will move because they are moving in the opposite directions. So this is left, this is right, this is left, this is right. Opposite directions, so opposite left and right. After each travels 1 kilometer, Shahid always turns left. So let us say this is 1 kilometer, turns another 1 kilometer, so this is left and this is right, turns another 1 kilometer, so this is left and this is right. Now similarly, Rohit always turns right and each travels 1 kilometer, so this distance has to be 1 kilometer, Rohit turns right, again 1 kilometer, this is right and this is left, Rohit turns right, this is another 1 kilometer. Now viewing this diagram, let us choose that option which gives the correct description of these two persons' movements. So after both have travelled 2 kilometers, the distance between them is 4 kilometers, is it? This is 1 and this is 2. So this is where Rohit should be after 2 kilometers. This is 1, this is 2. This is where Shahid should be after 2 kilometers. Now the distance between them is 1 plus 1, 2 kilometers. That is the distance between them. Whereas this option says the distance between them is 4 kilometers, which is incorrect. They meet after each has travelled 3 kilometers. Absolutely correct. 1, 2, 3. 1, 2, 3. Yes, they meet each other after each has travelled 3 kilometers. A very simple question. A similar question was asked in CSAT examination. Consider the following statements. There are 6 villages A, B, C, D, E and F. F is 1 kilometers to the west of D. Alright, let's start making the diagram now. F is 1 kilometers to the west of D. B is 1 kilometer to the east of E. Alright, let's put it somewhere. This is E and B is 1 kilometer to the east of B. To the east of E. A is 2 kilometers to the north of E. Now 2 kilometers to the north of E is A. C is 1 kilometer to the east of A. So this is where we shall have C, 1 kilometer to the east. D is 1 kilometer to the south of A. So D should be somewhat here. So D should be somewhere here. 1 kilometer to the south of A, which would also mean D is 1 kilometer to the north of E. Now we can fix this statement as well. That is, F is 1 kilometer to the west of D. Now, which 3 villages are in a line? Well, that's easy. A, D and E are the 3 villages which are in line given to us in choice B. Now location of B is north of A. Alright, so location of B is north of A. And location of C is east of A. So location of C is in the east of A. The distances AB and AC are 5 and 12 respectively. So AB is 5 kilometers and AC is 12 kilometers respectively. The shortest distance in kilometer between the locations B and C is going to be 13. You remember the Pythagorean triplet, 5, 12 and 13. This is again a CSAT examination based question. A started from his house and walked 20 meters towards east. Let's do it. So this is, let us say, A's house initially, and A walks 20 meters towards east, where his friend B joined him. So now this is where we have both A and B. They together walk 10 meters in the same direction. Now once again, another 10 meters in the same direction. Now we must maintain the scale as we draw these arrow marks. The arrow representing 10 meters should be smaller in length as compared to the arrow representing 20 meters. Now then A turned left while B turned right and traveled 2 meters and 8 meters respectively. So A turned left, this is left and this is right. A turned left, walked 2 meters, this is A, and B turned right and walked 8 meters, this is B. Again B turned left to travel 4 meters. So this is left and this is right. So turning left by another 4 meters. Who's traveling? B is traveling. Followed by 5 meters to his right. So this is left, this is right. So 5 meters is the distance covered by B to reach his office. So this is office of B. Now A turned right and traveled 12 meters to reach his office. So this is left and this is right. So A covers 12 meters to reach his office. Now what is the shortest distance between the two offices? So this is what we need to know. So this is what we must find out. The shortest distance between 2 points is always a straight line. So let us form a triangle here like this. Now this length shall be 2 here and 8 here. That is a total of 10. This length we know is 5. So if I form a triangle here, the vertical distance comes out to be 10 plus 5, that is 15. Now the horizontal distance from this point to this point is 12, but from this point to this point is going to be 4. This is a parallelogram, right? This is a parallelogram. So up to here it is 4, up to here it is. So from this point to this point should be 8. So we get an 8 here, and we need to find this distance. Pythagorean triplet, 8, 15, 17. So choice B here should be the correct answer. Should not take you much time. Otherwise, 8 square plus 15 square under root, that is 64, plus 225 under root, that is square root of 289, that is 17. Why should you waste your time doing all these things? So this is what is called preparation. You have to do certain things on your own before you enter into the examination hall. So 17 meters, choice B is the correct answer. Now PQR are 3 towns. The distance between P and Q is 60 kilometers, whereas the distance between P and R is 80 kilometers. Q is in the west of P. Now we know the positions. Now Q here is in the west of P and R is in the south of P. Alright, so R is in the south of P. And distance between P and Q is 60. And that between P and R is 80. So what is the distance between Q and R? Again Pythagoras theorem. Don't apply Pythagoras theorem. Apply Pythagorean triplet. So please observe, this is 3 into 20. This is 4 into 20. And 3, 4, 5 is a Pythagorean triplet, each multiplied with 20. So 3, 4 and 5. So 5 into 20, that is 100 kilometers should be your answer, which is given in choice D. So please do apply Pythagorean triplets. It will save you time and your accuracy will be 100%. So that takes us to the end of the session. I hope that you have learned the basic fundamentals correctly, registered them into your mind, and observed the types and varieties of questions which have been introduced in this session. We will meet again in the discussion of another topic. Till then, I wish you all the best. Please work hard, stay safe, and thank you so much.